Hi, so in this video we're going to look at solving equations using inverse operations. So an operation is just something that you can do to a number pretty much. So there are four main operations that we're going to be using. There are more, but we'll cross that bridge when we get there. So the four main operations you've been using for most of your life would have been plus to minus, multiply, and of course divide. So these operations actually come in pairs, specifically something called inverse pairs. And what the word inverse means is that they undo each other. So these are the pairs plus and minus, times and divide. So what this means is that simply they reverse each other. I'll show you what I mean by this. So if I've got number 2, for example, and I add 3, but then I also take away 3, without any calculation whatsoever, I know that the answer here is going to be 2 because I have a plus 3 and a minus 3, which will cancel each other out. And the same principle here, if I have something a bit harder, like 47 times 15, but then I divide by 15, there's no calculation necessary because times 15 and divide by 15 will cancel. And my answer will just be 47. And feel free to check that on a calculator if you like. 47 times 15 divided by 15 will just get you back to 47. So we're going to use these inverse operations, or this idea, to solve equations. So the way most equations will come up will be, we'll start with these one-step solves. So you'll get something like x plus 2 equals 5. So the idea is that an equation is much like a scale in that the left-hand side and the right-hand side need to be balanced at all times. So whatever you do to one, you must do to the other. So what we can do, the whole purpose of the word solving, we're solving. What we're looking for when I say solve is we are looking for the value of this x. So what we do is, we reverse plus 2. So what is the inverse of plus 2? Because we want to remove everything from this x pretty much. We want this x on a side on its own. And by doing that, we actually find what x is. So if we minus 2 from both sides, so plus 2 and minus 2 will cancel. So on the left-hand side, I'm left with just x. And on the right-hand side, I'm left with 5 minus 2 equaling 3. So from this, as you can probably see from the start, x was 3, truthfully, so something plus 2 is 5. So yeah, x is 3. But this is the formal way of doing it, and this will be a lot more important when we get to harder examples further down the line. So let's do another one. Let's do 3x equals 12. So 3x means 3 times x, effectively. So x is times by 3 and gets 12, and we get to 12. So now it's the same principle. We want to get x on its own. So x is times by 3. So to undo this, we divide both sides by 3. So we use what's on this x to decide what inverse operation we're doing, but then we apply it to both sides. So x times by 3 and divided by 3, that will just give me x. And then that's equal to 12 over 3. So 12 divided by 3 is 4. So x is 4 in this case. And that's how we go about solving the one-step solves. And I will do one more example, and there'll be a worksheet linked for you to have a go at after this. So let's try one more. So let's try x over 3 equals 9. So to solve this, we look at what's on the x, like I said before. So x is divided by 3 to make 9. So we look at the inverse operation of dividing by 3. So the inverse of dividing is multiplying, as written at the top. So we're going to multiply both sides by 3. So both sides are multiplied by 3. And now these will cancel. So I'll get x on its own. And x is equal to 9 times 3, which is 27. So 27 is my answer in this case. So there'll be a worksheet attached. Have a go and go until you're confident.